In this video we're going to be looking at solving equations with modulus functions. So we're going to look at three examples here. Let's go for the first one. Mod of x plus 2 is equal to 6. So in each of these cases I'm going to show you graphically what's going on. Drawing a sketch can be very useful in identifying how many solutions you expect to find and also identifying kind of where those solutions should be to make sure your algebra is right. So the modulus of x plus 2 looks something like this. Okay? Where this point is minus 2. And we're looking at where this intersects the line y is equal to 6. So we can see that it is intersecting our graph at 2 points. And so we want to find where these points are, the x-coordinates of those points. So what we can do is we can look at the intersection of x plus 2, the line x plus 2, with 6. And we can also look at the intersection of this line, which is minus x minus 2, with 6. And solve those two equations independently. So this equation will get x is equal to 4, and this equation will get add 2 to both sides is 8, so multiply through by minus 1 and we get minus 8. So this point is minus 8 and that point is 4. Okay? And so those are the two solutions that we would get from that problem. Okay? So that is the first one. Let's look at the second. Mod of x minus 3 is equal to mod of 6 minus x. So we're going to sketch these first. So the modulus of x minus 3 looks something like this. Okay, that's 3 there. The modulus of 6 minus x will look something like this. Okay, so when x is 6, I get 0, so that's why that point, the vertex point, would be there. And what we can see is that these two lines are parallel, and these two lines are parallel, so there is only one intersection point. And that is the intersection of, in this case, x minus 3. Okay, that's that line. And this line is 6 minus x. So we can add x to both sides, add 3 to both sides, okay, would be 9, and so x is 4.5, or 9 halves. Or from the graph, you can actually see through symmetry that that point must be 4.5. Okay, halfway between the 3 and the 6. So that's how we can do question 2. And then number 3, we have modulus of x plus 3 is equal to modulus of 2x plus 1. So let's sketch these. So x plus 3 would look like this. That's the modulus of x plus 3. Then the modulus of 2x plus 1. So that would be something like something like that. Okay, because of that 2x, you're going to have a steeper gradient. So that's the point minus a half. And so we can see that there are two intersection points that we need to find. So this line, which intersects both of those, that line is x plus 3. So we've got x plus 3 intersecting two lines here. We've got 2x plus 1 will give us this point here, and this one is minus 2x minus 1. So if we solve both of these independently, add 2x to both sides for the first one, we get 3x. Take 3 from both sides is minus 4. So we get x is equal to minus 4/3. So that would be this point here. And then solving this one, we can take 1 from both sides, take x from both sides, so x is 2. And those are the 2 solutions to that problem. The sketch showed us that there had to be 2 points and showed us which equations to put equal to one, or which graphs rather, we should put equal to one another.